I bought this knife blade from Heinnie in the UK, and it's what they call a blank, which means basically it's the blade without a handle. I've always wanted a Damascus steel knife, and there was just something about this Tanto style blade which I found very aesthetically pleasing. My intention was to make my own handle out of wood, but as I'm trying to think of more 3D printing projects to do, I thought I would try 3D printing a handle and to see how it would come out. I'm still very much new to the world of 3D printing, so this video isn't intended to show you how to do this in a very specific way, but it shows you how I have approached the project, working things out as I go and trying to make a handle with the limited knowledge and experience I currently have of 3D printing. I'm sure there are better and more efficient ways to do it, but this way worked for me, and as I learn more I will find out what those better ways are. So, to make my knife handle, I need to create a template for the handle itself, but in such a way that I can get it into the computer. So the first thing I need to do is take measurements. So here we can see I've measured the handle in lots of different ways, from one end to the other, from side to side at various parts of the handle, in order to get the slight contours accurately measured so that I know exactly the width and length in various places. So the next thing I need to do is basically to get this into the computer. So the idea I came up with was to take a photo of the handle and then import that as a template into software. Now, one of the difficult things is knowing which software to use. So I basically searched on the internet and I found a lot of people referring to and recommending Fusion 360. I was looking specifically at how to import images into 3D software and then how to trace those images so that you could develop a 3D model from it. And Fusion 360 seemed to be the best way to go. There's actually a free version available for non-commercial use, and in the next section we're going to look at how to create a template 3D model from an image. So here I am in Photoshop, and I was going through all the various photos I took, and this is probably one of the best ones of the handle. Now, one of the things I want to do is to actually cut out the handle from the background so that I can more accurately work with it as a template. So to do that, essentially, is use the magic wand, and I've set it at a tolerance of 21 at the moment, but the idea is that I go around the image and just making selections. You see that's slightly too much, so do Control Z, come back to that. That's slightly too much, and my tolerance is a little bit too high, so I set that to 15, and basically start again. And bit of a long-winded process because it's just about getting the tolerance level, and then I set the selection and deselection to go round. So a bit of a painstaking process of actually trying to get it as accurately as possible and to get the center holes as well. I probably won't use pins and I probably won't have that hole, but I'll put them in the model anyway. So after a bit of time, essentially I've come up with this. So we got a nice clean crop all the way around, and that is basically going to be my template, which I then save as a PNG file, and that's the file I'm actually going to import into Fusion 360 as part of the next stage. So here we are in Fusion 360. This is a new and untitled project. So the first thing I want to do is I want to press L, and that L will basically allow me to create a new line, and then I click where I want the line to start. So the first thing I'm going to do is just move over a little bit, so click on L and then place my first point, and then I can actually set the length that I want the line to be. So the idea of this is that I'm going to use the line as a length indicator for the scale of my image, so I know that the image is then an exact sized template for the knife handle. So I want to make it, if I make it 105 millimeters initially, so that's 10.5 centimeters, and I don't want to continue the line, so I just press escape. Now actually I want the line to be 105.22, so I zoom in so I can actually see more of a grid. Keep going, keep going, keep going, keep going, keep going, and then at this point I should be able to, if I move this, so if you look down the bottom right hand corner, so 105 point, so I'm looking for 105.22, there you go. So that is now an exact length, and that matches the measurements I took of the knife handle earlier. So I zoom back out, and then what I want to do is I want to upload or import the knife handle image or the template. So I click on insert, and then I insert canvas, and then I insert from my computer, scroll down, select my template, and then basically I've got this little placeholder here, but if I click in the placeholder you'll see that the template then appears. So then what I need to do is I need to make sure that my template is as the correct dimensions. So basically I move it to the middle, and then I use the tools there just to be able to expand the image, try and get this as close as possible, and then do it a bit more. So we need to move that over just a little bit, there we go, and then I can expand it a little bit more. So basically just trying to get it as exact as possible. And then if I press return and then I zoom in, you can see it's not quite up to that edge, and it's not quite up to that edge, so we just need to expand that a little bit more. So click. So it's this template, canvas template, so click on there, edit canvas, and then just increase that a little bit more, slightly too much. So what I might do is, so where you can see there the scale plane, so I'm just going to make that 1.5. So the sizing is one thing. We know that this is now 105.22, which is the measurements we took earlier. So this is effectively our template for the handle model. So the next stage is actually quite time consuming. So this is where we're actually going to use the fit point spline, and then basically we're going to click, as going around the image, we're going to click, 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 and we're going to create lots of individual points so that we can accurately map the contours of the handle, so that we can make our model as exact as we can to fit those contours. Now, to save time with this, this is one I did earlier, and after creating the spline, which is then effectively a flat body, or as this calls it, but a flat model. So then what I did is I selected it and extruded it by a height of 3 millimeters. So that what that then gives us is essentially this. So you can see you've got the image, the template image behind this particular model, and you've also got the thickness, you've got a 3D model itself. So if I highlight, or sorry, if I deselect the template, you can see that the knife template image disappears, and if I show the template but hide the body, you can see how we've got the actual template itself. So you can see how the body of the 3D model fits the template, and fits it very accurately, basically because I've just created so many different splines all the way around the model to ensure it's as close and as accurate as possible. So then once I've done that, I save it. So as you can see, I've saved it here as knife handle, no holes. And then what we can actually do is we can export that as a model. So basically, if we click on body and then file and export, and then we can export it in a number of different ways. So basically I exported this as an object file, and then also as a STL, but it's obviously the STL that we're going to be using. I just wanted to make sure I had it as both an object and an STL. So once we've exported it as the STL, now we can proceed to the next stage. In the next stage of this process, I want to import my model into Blender and then decide basically what I'm going to do with it. So I've created a new Blender project, and I click the cube that's created by default and I press delete. So now I click on File and then Import, and I want to import the STL file that I exported previously. So I go to my folder, so here we can see the file, the object, and I zoom out, and so basically what it's done is it's put it into this particular position where it's halfway through the bed basically. So what I'm going to do is I'm going to select it, and then I'm going to rotate, and then I'm going to rotate it so that it's actually 90 degrees the other way, and as you can see on the right we've got more precise control over this. So I could have just typed 90, but there you go, 90. Now in fact actually the opposite way round, because this is actually the opposing side, or it should be. So what I also need to do is I need to rotate it around the other way, like that. So that's 270 degrees, there you go, precisely. So that puts it nicely on the bed, and it's exactly the orientation we want, because this is going to be, if you're looking down the knife from handle to blade, this is the left hand side. So I want to make sure I do the left hand side first. Now when looking at this, I'm wondering what to do. Now I could add a little curve, I could add a texture, but one of the things about this particular model is that it's made up of lots of vertices. So as in the previous process where I basically added a point for every single part of the edge of the blade or the handle, the part of the blade that's the handle that I traced, that's what gives this unique shape. But actually what I've got is I've got lots of vertices here that could be updated, modified individually, and what that might give us is actually a really interesting kind of faceted effect. So basically the idea I have is to go round it, and if I go into, so I'm in edit mode, so if I select a vertices and then if I try manipulating it, you can see we can do interesting things with it. So what I'm going to do, rather than, because this is a really time consuming process to actually modify every single vertices or every single alternative vertices on every single point of a particular model, I'm going to load in one that I did earlier. So here we have the updated knife handle. So basically, as you can see, what we've got is we've got alternating vertices or points and vertices. So basically what I've done is I've selected each one individually, pulled it down slightly, and then pulled it in. So literally select, come down from where it was originally, and then in, and that gives us this very slight, subtle effect. That one's a little bit more exaggerated now. So actually we've got peaks and troughs, effectively, these ups and downs of each kind of alternate vertices on the model. And then as I came around to the end, because there's more of these to follow the curve of around the corner, I selected, still selecting each one individually, alternating one after the other, one down, one up, one down, one up, and you can see we've got this very subtle, or what should hopefully be subtle, effect. And then as we come around the end, I've come down with many of these, so it's going to slope down from the top or the back here down to the bottom, so the back is effectively a little bit higher over here. And then as we come around the back, we've got the alternations between up and down, in, and that gives us this really, I think, hopefully what will be quite a unique effect. It's only obviously when it comes out the printer I'll know exactly what it looks like, but I've got to, it sounds or looks as though it might be quite interesting. And then as we come over to this point where basically the handle meets the blade, or the brass bit on the blade, what we can see here is I've actually pulled it down slightly, so it's going to actually hopefully meet the brass quite effectively, and again slightly down on this corner, so it kind of basically slopes up as it's coming out of the brass, and then alternates. So hopefully that should be quite an interesting effect. Now, one of the next things I thought I'd do is, even though I've got what hopefully is going to be a very interesting and unique knife handle itself, is I was going to put my initials in the blade itself, so quite discreet, basically to cut out the text from the handle so that the initials are embedded within the handle rather than sticking up proud. Anyway, so this is a bit of a process in itself, so I thought I'd include this in the video as well. So essentially what I've done is I've got my original handle model here, which I did a moment ago, and then I've imported a text model from another file which I've done previously, and you can see this is actually a text layer. So the first thing I need to be able to do in order to be able to utilize this as a model which I can cut from this model, or a shape from this shape, is I need to convert this into a mesh. So if I right click on that and then convert to mesh, you'll see it's changed the symbol so that it's the same as the knife handle blade. So then what I can do is I can actually move it into position, and if I move it like that, you can see how I'm moving one layer from over the other. So then what I need to do is basically select the bottom layer and then go to modifier and then add modifier and then boolean, and then I select the object which is text, and then basically I can cut one from the other. Now this took me a while to get all the layers right, and also the positioning and sizing right. So what I've done is I've actually prepared earlier. So as you can see, I've basically orientated it so it's going to be quite discreet in the corner, just tucked away, and I've got my height just right. And then I've done my boolean and I've got my modifier, and if I deselect it, you'll see it's quite discreet. There it is in the top left hand corner. So when you consider the depth of this is going to be 3mm, it's just a very slight indentation, and it's actually not that big, so it is quite discreet basically. So that is now our finished model. So I'm going to export that as a STL file, and then the next stage is where we can actually import that into the slicer and then get it ready for 3D printing. One of the important things to remember when using booleans is to export the main object itself and not the object that you're actually cutting out or using to cut out, because otherwise if you didn't do that, you'd end up with like a complete model, and you wouldn't actually have the cutout. So by making sure that the boolean is in effect, and we can see that we've got our little, I select the main shape, the main handle, click on File, then Export and STL, and then on the right hand side you've got Selection Only. So that's very important because you actually want to ensure that you're only exporting the selection only, which is the main knife handle. So once that's done, that's it. Now that's ready for slicing. So here we are in Repetier, and I'm going to import my knife handle, and there it is. And you can see, if I just move it around, you can see the textures and my initials in the top right hand corner. And so there it is, and it's in the center of the bed. Now I happen to use Repetier because it was on the memory stick that came with the artillery sidewinder, so it's the first slicer I used, and actually I quite like it. It's nice and simple, and I seem to get quite consistent results, good results from it, and the print time seems to be quite good. Sometimes it's quite a bit quicker than using Cura or Prusa, so maybe the settings just aren't quite as refined, but either way I should hopefully get a good result. So then I click on slicer, and I'm going to not have a brim. I'm going to see how it comes out without a brim. I'm going to clean the bed first of all, and that should give me good bed adhesion, and hopefully everything will be okay. And click on slice with Cura engine, and there we go. So this is going to take 26 minutes 27 seconds, and it's going to use 1.9 meters of filament. So let's send this to the printer and we'll see how it comes out. So in the final stage, we're now going to send the G-code that we generated from our slicer to the artillery sidewinder. Now I really like using Octoprint. It's a very convenient, very easy to use, very handy interface to the printer, 3D printer. I can access it through the network, and through the terminal I can actually view and record the print as well. So it's really great, and I'd recommend anyone to use this. I've already got the bed up to temperature just to make sure everything was level, and I've got the print head up to temperature basically because I've just loaded the filament, a black filament, ready for printing. So the next thing I want to do is click on upload. There we go, knife handle raw, and basically I can now set it to print. So if I click here to load and print, it then loads it and starts printing. And then using the terminal, the control I should say, there's the bed, and we can get a good view of the print it's printing, and then we'll see what it comes out like afterwards. And here we have the result of the 3D printed knife handle, and it's not bad. One of the things that I notice is it's a bit too thin. I'll come back to that in a moment. The texture is not quite as good as I imagined it to be, and I think probably because we were talking at such low resolutions. You know, when you consider the model's only 3mm deep anyway, when you actually look at the depth of some of those troughs and the heights of the peaks, it was quite a fine resolution to actually print. The edges could come out quite nicely. You've got those faceted effects, and the fit's not bad. One of the things I noticed is that it's slightly too long, and that's probably because of the bit of the handle I included within the measurements, which I shouldn't have done. But in terms of fitting side to side, that's fine. It's a nice flat edge, so it meets the handle okay. I love the fact that you've got those facets on the edges as well, which catch the light, which is really nice. So all in all, not bad, but it's a bit too thin. At 3mm, it only makes the whole width probably about 1 centimetre, which just doesn't feel right in the hand. So I need to print it again, and it needs to be thicker. So as we found from the printed knife handle, it was too thin. Now the original idea I had was for it to be quite low profile and to be about the same depth as the hand guard really, but actually it's too thin, and it just doesn't look right, and it doesn't feel right in the hand. And so what I need to do is I need to increase the depth or the thickness. If I click on N, this shows me the z-axis. The thickness is currently 3mm. If I click on transform, and then what I can actually do is I can increase the depth of this. Now, one of the good things about this is the fact that it's actually because it's increasing the height of the model with all of the splines and the points. It means that everything's been scaled. Even these facets are also being scaled, which is good. Now, when I measured it, around 5.5, 5.6, 5.7 millimeters would probably be enough. It's almost twice the thickness. Plus, also when I've done the other side as well, and you've got the handle as well, which is about 3mm. So it's going to be, what's that? 1.4, 1.5 centimeters thick, which I think is probably fine, because it's quite I don't want it to be a chunky handle. I want it to be low profile, and I want it to be almost quite sleek. So I think that is probably sufficient, because it's almost double the thickness of what it is at the moment. And I think I've got both sides on it. It'll probably be okay, actually. And also, one of the other things we found was that the printer hadn't printed the peaks and the troughs quite accurately. And I think basically the reason for that is because we're actually looking at quite a small gradient. So, when you consider that the height of some of these peaks and troughs is probably less than 1 millimeter, it was probably just a little bit too much for the printer to try to print with that accuracy. Or my settings on the printer weren't accurate enough. So what I'm going to do is I'm going to export this model, and because one of the things that's gone now is my initials have gone, because we need to actually move those up into the top of the model. So I'll sort that out in a moment, only because that's a bit fiddly, just to get the positioning right again. But essentially I'll then export this again, and then put it into a slicer. But I'll probably might try Cura this time, just to see how it comes out with Cura, because I think one of the things I've noticed with that is while the prints take longer, I think it's because the settings are set for it to be a higher resolution or better quality, basically. So we'll see how that comes out. Right, so let's sort out these initials then. It's okay. There's probably a couple of millimeters of depth there, so that's fine. So right, so what we need to do now is File, Export, STL, and we need to make sure that Selection Only is set, because we want to select only this with this extracted, and then we'll call this thicker. And then export. Okay, so on to the next stage of slicing it. So here we are in Ultimaker Cura, and I thought actually the first thing I'm going to do is I'm going to drag in my original handle, which we can see there, and then I'm going to drag in the new handle, the thicker version, and drop it there. And what we can see here is the size differential between the two and the height. So it's almost double the thickness. So I wanted to see that for myself, just to make sure it looks okay. And also the other thing I was thinking is I wonder what the difference would be if I sliced the original handle in Cura, what the difference in the printing time would be. So if we slice, this says it'll be 52 minutes. Now when you consider it was just over half hour, or around half an hour from Repetier, and it's 52 minutes from Cura, this is what I tend to find, is that prints seem to take longer, sometimes almost double the amount of time, when slicing through Cura. And I'm sure that must be settings related. I don't know what the settings are. I'll have to do a comparison, or the difference in the settings. I'll have to do a comparison one day, but it's interesting to observe. But it'll also be interesting to see how this comes out. So I copy in my, or drag in my thicker version, and there it is, right in the center of the bed. And so basically now slice, and that's going to take 1 hour 9 minutes, and it's going to use 3.34 meters this time, which is quite interesting. So I'm going to save this now, and then we can copy that up to the printer to print with Octopi. The next stage in the process is to upload the GCode file to the printer. So I'm going to upload, and then click on print. Printer will start in a moment. So the bed is already heated up, just making sure that's level and clean. The print head will need to get up to temperature, but as we can see here, it's approximate 1 hour printing time. So let's see how it comes out. So as we watch the print, we can see that the first layer is pretty much solid, and then the next layers are the lattice that goes inside to give it structure, and then a lot of the time is actually spent doing the surface and doing the peaks and troughs and the textures of the top surface. And that came out so well that I thought what I'd do is I'd prepare the other side of the handle. So I loaded it into Blender, I mirrored it so I could turn it around, I exported it as an STL file, loaded that into Cura again, kept all the same settings, and sent it to the printer using Octopi, and here we have our finished knife. Cool. And here we are. So using the original blade from Heinnie, also got a knife stand as well, which is really nice actually, also from Heinnie. And this is it. This is the finished knife handle, and I have to say it works really well. I think the black of the filament goes really well with the very dark grey of the Damascus steel. You've obviously got the waves and the patterns in the Damascus steel, but you've also got the kind of the intricate pattern work of all the peaks and troughs of the handle itself. So I think even though they're not waves, it's still kind of wavy and liney and all different angles, and I think it just works really, really well. I'm so pleased with that. I can't believe it's come out quite as well as it has. You have an idea when you're putting these things together that it should be okay, but it's only really when you finish it and can see it, you kind of, so appreciative that it's come out okay. And around the edges as well, on the top and the bottom, where you've got the that texture where all the peaks and the troughs and the edges and the vertices have all pulled it in different directions. On the top and bottom edge, it creates a really nice grip, and it fits really well in the hand, and it feels nice. So I'm really, really so chuffed at how this has come out. I'm very, very, very pleased, both aesthetically and also physically to hold as well. It's got good texture to it, got good grip, and it just looks really, really good. I think I'm so pleased, and considering that's my first kind of one of my first complete projects. Certainly on a project where I've created it from start, from initial idea through to the original template, through to the original models, and then exporting those, sending them to the printer, learning from my mistakes, redoing things in order to kind of get to the end point. I'm just so pleased with this, and that's one of the reasons why I wanted to share it, because it's been a bit of a journey for me. It's taken a great many hours, but hopefully it might be of interest to someone, and I'll share the files as well, and you can do with them as you wish, and I hope they help you. So thank you very much for watching.